function?
You have your slope and what stuff.
So what are they?
2 is your slope.
So m is 2, and what's 9?
0, 9.
0, 9 is the what?
Y.
The y-intercept is 0, 9. The y-intercept is 0, 9. Can you tell me anything else about it? There's something else you can tell me.
Straight line.
Well, that's what linear means, yes. No, it is a line. I mean, linear means straight line. That's fine. What else? You can tell me the y-intercept. What else could you tell me? What's the x-intercept?
It's 1 y equals 0.
When y equals 0. So when y equals 0, what does x equal?
Negative 9 over 2.
-9 over 2. So the x-intercept, how many x-intercepts does this have? Because it's a line, it can only have one. Exactly. There's only one type of line that has no x-intercept. What type of line is that? Y, a horizontal line, like y equals 7, something other than y equals 0. Okay, so this function takes a bunch of input values and turns them into a bunch of output values. Let's say I want it to go in reverse. So everybody has their surfaces flat because you've remembered what I've told you literally every day for this entire, oh look at, they're all going flat. Oh, it's so good. It's all good. It's okay. It's okay. If I want it to go in the other direction though. So this function right here takes a bunch of values, a bunch of input values, and turns them into a bunch of output values. Let's say I gave you a bunch of values that were in the input, that were output values, and I wanted to turn them back into input values. I would need to use the inverse function. You might have read about that in your notes, right? 10.1, wasn't that the homework last night? Something like that? 10.1 inverses? Amazing, right? So, without saying it out loud, on your surface, can you figure out what the inverse function would be? Do that now. Tell me what, don't tell me, but figure it out so you could tell me what the inverse is. Figure it out so you could tell me what the inverse is.
Switch x and y.
Yeah, so they say switch, and I've said switch for years. The thing is, could you have multiple x's theoretically in a function? Yeah, x's could be in multiple places. So it's not really switch, it's more replace all the x's with y's and replace all the y's with x's. So the first thing you do is replace. And when you replace, what are you going to end up with? You're going to end up with x is equal to 2y plus 9. After you replace, what's one word for what you need to do next? What's one word? Solve. What's one word? Solve or isolate. Yeah, but if it was one word, solve or isolate. I'm trying to give you something to make it easier to remember. So isolate. And what are you isolating? You're isolating y. So if you're going to isolate y on this, what do you subtract first? Maybe x minus 9 is equal to 2y. And then you could divide everything by 2. So you have y is equal to x minus 9 over. Another way to write that would be 1/2 x minus 9/2. You with me so far? Okay, so what I'd like you to do right now is do the same exact thing. Do the same exact thing. Let's say it was f of x is equal to, let's say, x plus 7.
It always messes me up when you put it in f of x.
What is f of x mean?
And then y.
It's just another, it's y equals x plus 7. Yep. So what do you subtract next, Sarah?
For the inverse,
Yeah, we're going to solve for the inverse.
we're gonna
What do I do first?
replace.
Yep. So it's going to be x is equal to, exactly. So then what do you subtract?
7.
X minus 7 equals y. Y equals x minus 7. I'm just reversing the order right there. So we have, so this right here is the function, and this is the inverse.
I have a question.
One sec. This right here is the function, and this right here is the inverse. So let's just write down what we have. We have the function and the inverse. So the first one, let's call it, so it was y is equal to 2x plus 9, and the inverse was y is equal to 1/2 x minus 9 over 2. And then we had y is equal to x plus 7, and what do we get over here? Y is equal to x minus 7? Like that? Y is equal to x plus 7, y is equal to x minus 7.
Wait, you scroll forward? Yeah.
Sorry. You also have this, theoretically it's syncing with your notebook, theoretically. Take a look at those and make sure, with lines it's pretty straightforward. So if I have f of x, if I had f of x is equal to, let's say, 2/3 x plus 5, Yeah, it's a little bit different because there's a fraction, but does the work change to find the inverse function? Does the work change? No, it doesn't. It doesn't at all. So here's what I'd like you to do now. Think about this. If I gave you this graph right here, y equals x squared, without talking to anybody on your own, I'd like you to think about what does the inverse look like and how would you go about graphing it? By yourself, no questions to me, no questions to anybody else. What would the inverse of that look like? What would it look like and how would you graph it? You can sketch on your surface, go right ahead. But reflection, exactly. So if you draw y equals x, it approximately looks like this. So if you reflect over the line, there are 2 points that don't move. Can you tell me the 2 points that don't move? 0, 0, and?
That intersection.
Yeah, 0, 0, and what's the other intersection? Oh, come on, kids.
4, 3.
Gabby, put the calculator down.
4.
Does 4 squared equal 2 squared?
4, 2.
Does 2 squared?
2, 4.
Does 2 squared equal 4 squared?
No.
Or 16.
4, 4? 4 squared equals 4 squared.
Does this, it has to be in both lines. This is y equals x.
1 squared.
1, 1. Thank you very much. Well, I couldn't. Great. Okay, Birdie said it. I did not hear it. I heard a sea of numbers that don't work. I did not hear it. I did not hear the clarity of the proper answer in the back. I am sorry. So, those 2 points are the same. I saw Hannah doing something good, which was using her hand and like reflecting her hand. You reflect over that line. So what is this actually going to look like when you reflect it over the line? Well, you could. One thing I used to do years ago was with paper, you'd use pencil lead and like you'd shade in the function, and then you'd fold the paper and like pat it together, and you could actually see the imprint. What this looks like is this.
See the dust?
Yes.
It looks like this. If you were to take the board and fold it over y equals x, this will turn into that. This is what it looks like. What can you tell me? What would be the equation for this gray function right there? X equals what?
X, Y squared.
X equals y squared, right? What can you tell me is a little strange about this relationship right here, this path?
It overlaps with the same points at
It
different
overlaps in 2 places here, right? But what does it overlap with?
Negatives.
Negative of itself.
Yes.
Itself. This is a function. This is not a function. Why is this not a function?
Doesn't pass the
Doesn't pass the vertical line test, exactly. Are there a lot of vertical lines that pass them more than once?
Yeah.
Yeah. Here's the thing. This is a function, but this is the inverse of this function. Is the inverse of a function necessarily a function?
No.
No. There's a certain type of functions whose inverses are functions. You learned it in 10.1. You remember what the name of those functions are? One-to-one functions. One-to-one functions. Is this function one-to-one?
Yes.
No, it is not. Because
Because it's not a function. When
Because its inverse is not a function.
Yes.
This is not a one-to-one function because its inverse is not a function. How do you tell if a function is one-to-one or not? Hint. How do you tell if something's a function? It passes the... Something is a one-to-one function if it also passes the horizontal line test. Does this pass the horizontal line test? No. So therefore it is not...
Wait, what is it? I'm confused by that.
Let me finish the sentence and then you can ask your question. Does a vertical line pass through more than one point?
Yes.
So does it pass the vertical line test? No. If it's not one-to-one, if it's not, doesn't pass the vertical line test, it is not one-to-one. So that means it's inverse, because here's the thing. What happens to a horizontal line when we flip it over to the green line? Turns into a, so if it doesn't pass the horizontal line test here, it won't pass the vertical line test here. If this doesn't pass the vertical line test, it's not a function. It's not a function. So I could give you a picture and I could say, is this a function? How do you tell if it's a function or not? If it passes the vertical line test, it is a function. How do you tell if it's a one-to-one function? If it also passes the horizontal line test. If it also passes the horizontal line test. It also passes the horizontal line test. Algebraically, you can figure this out though too. This right here, do we like things in y equals or x equals? We like y equals. That's what we've been dealing with the entire year, right? So we need to isolate y. If I want to isolate y right there, what do I need to do to both sides? Okay, so it's going to be y equals what? What else? Yes, when you add in a square root, what do you have to put in there? Positive. So where is positive square root of x, do you think? Oh, that's here. Where's negative square root of x? Below, right there. Exactly. Because on your calculator, what can your calculator graph? Things in y equals form. So if you ever wanted to graph this, how many functions would you have to type in?
Two.
2. Y equals the square root of x and y equals negative square root of x. You're going to do that sometimes. That absolutely is going to come up. It's absolutely going to come up. Okay, so this is what I'd like you to do. The line. So if I go from here to here and it's perpendicular, where do I have to go? Oh, this distance has to be the same and perpendicular. So you can do one point at a time that way. So like if I'm here and I go to here, I better go the same distance away to there. Does everybody see how that works?
Yeah.
When you're really lost, do one point at a time and then connect them. Sometimes this is really hard to do. Yes?
So the vertical line has this, like, it can't hit 2 points in one.
Yes, and if it doesn't pass,